All right, welcome to the Explainer. I am super excited to dive into today's topic with you. We're tackling a totally foundational skill in cloud computing, how to effectively and safely change an AWS EC2 instance type. Look, whether you're scaling up to handle a massive spike in traffic or you're scaling down to stop burning cache, this is an explainer you're gonna want to stick around for. So we've got to start with a real talk question. Is resizing an EC2 instance actually as easy as just hitting change in the console? I mean, it's a super common assumption, right? People kind of picture this process as a tiny, harmless little ice cube floating in your drink. But actually, it's a massive iceberg. What looks like a conceptually straightforward, simple click up on the surface is hiding some incredibly complex compatibility checks and some pretty serious gotchas lurking right beneath the waterline. Okay, let's dive right into this. Here is our roadmap for today. We're going to cover the stop change start myth, the pre-change checklist, execution steps, what changes versus stays, and finally, some absolute best practices. Starting off with Section 1, the stop, change, start myth. Sounds deceptively simple, doesn't it? Yeah, the biggest myth out there is that changing an instance type is just 3 easy steps. Stop the instance, change the type, and start it back up. And sure, functionally, those are the literal buttons you click, but relying purely on that logic, that is incredibly dangerous. It's kind of like a car, right? You can't just casually swap out a standard engine for a massive high-performance race car engine while you're cruising down the highway without first checking if the new engine actually fits the car's frame. Compatibility is absolutely everything here. Which brings us to Section 2, the pre-change checklist. Let's plunge underwater and look at these critical gotchas. First up, your instance absolutely must be EBS-backed. If you're running an instance store-backed instance, you simply cannot change the instance type. End of story. Next, spot instances. You can't change the instance type of a spot instance at all, so don't even try. Now, let's talk about auto-scaling groups, or ASGs. If your instance is part of an ASG, you've got to suspend your scaling processes first. Why? Well, because the exact moment you stop that instance to resize it, the ASG is going to immediately mark it as unhealthy. It might terminate and completely replace it before you even finish making your change. And finally, just keep in mind that not all instance types are available in every single availability zone. You might try to switch to a fancy new type and hit a wall simply because AWS literally doesn't have that specific hardware sitting in the rack where you need it. And this brilliantly illustrates our next major hurdle, architecture matching. You cannot just seamlessly hop between an x86 architecture, your standard Intel or AMD processors, and an ARM architecture, which AWS calls Graviton. An x86 AMI simply will not boot on Graviton hardware, and vice versa. It's like trying to play a PlayStation game on an Xbox. If you want to change architectures, you actually have to change the entire underlying AMI. We also really need to look at your virtualization type. If you're working with a super old AMI that relies on paravirtual or PV virtualization, you're pretty much stuck with legacy instance types like T1.micro or M1.small. Modern AWS instance types, they strictly require hardware virtual machine, or HVM virtualization. So out with the old, in with the new. So what if you're trying to do a massive generation leap? Say you're moving from an older Xene-based generation like an M4 or R4 all the way up to a shiny new Nitro-based type like an M5, R5, or M6i. You've got to ensure your current instance has the Elastic Network Adapter, or ENA, driver installed, and you need that NVMe module enabled too. On top of that, you absolutely must confirm your etc/fsab file is using UUID-based entries, not those old device names like /dev/xvda. If you skip these checks, your new instance simply will not boot, which, let's be honest, is basically every cloud engineer's worst nightmare. But hey, the good news? AWS actually provides a really handy compatibility check script for this exact scenario right in their AWS Support Tools GitHub repo. Okay, I need to put a massive, flashing neon warning sign on this next point. If your instance has a public IPv4 address, and that address is not an elastic IP, you are going to permanently lose that IP address the very second you stop the instance. When you boot it back up, AWS is just going to hand you a completely new, totally random public IP. If you've got DNS records pointing to that old IP, boom, your site is going down. Always, always, always use an elastic IP if you need that address to stay put. All right, we survived the checklist. Section 3, step-by-step execution steps via the AWS Console and the CLI. If you're someone who prefers the AWS console, you'll navigate over to your EC2 instances, select your target, hit instance date, and then stop instance. You gotta wait until it fully says stopped. Then head over to Actions, Instance Settings, and click Change Instance Type. Just pick your new type right from the dropdown. Oh, and you might see an optional toggle to make it EBS optimized. Definitely flip that on if the new type supports it. Click Change to apply, head back to instance date, and hit Start Instance. Once it's up and running, reconnect and validate your app. Just one quick aside, for the Windows users out there, if you're running Windows Server 2016 or 2019 with EC2 Launch version 1, you'll need to run the initialized instance.ps1-schedule script after you make this change just to ensure everything routes correctly. Let's move to the command line and see how this builds for scripting or automation. Here is your AWS CLI workflow. Step 1. You run AWS EC2 stop instances. But crucially, you then really want to run AWS EC2 wait instance stopped to make absolutely sure it is fully powered down before you proceed. Honestly, that's a step a lot of junior devs just totally forget. Step 2 is the actual change. You run AWS EC2 modified-instance attribute, passing in your instance ID and the new instance type value. And finally, step 3, you run AWS EC2 start instances, followed up by the wait instance running command. Boom, done. Moving right along to section 4, what changes and what stays. Let's talk about what to actually expect. So the crucial point is really understanding this exact breakdown. On the preserved side, your EBS volumes and all your data, they remain perfectly intact. Your Elastic IP association stays. Your security groups, IAM roles, tags, and your internal private IP address all stay exactly the same. But on the ephemeral side, like we warned about earlier, a standard public IPv4 address is going to change. The underlying physical host hardware sitting in the AWS data center changes. Any temporary data on available instance store NVMe volumes completely wiped clean. And of course, your compute resources, like your CPU, your RAM, your network baseline, those all change to match whatever new type you just selected. And that brings us to our final section, section 5, pro tips and best practices. All right, first rule of Cloud Club, always take an AMI backup or snapshot before making a structural change. If the instance fails to boot on the new hardware, you want an immediate rollback path, no questions asked. Second, if you're doing a huge generation jump, test it out with a non-prod instance first. Launch a clone from your AMI, boot it up, and run checks like DMSG to look for driver errors or LSBLK to make sure your disks are actually detected. Third, let AWS do the heavy lifting for you. Use the free AWS Compute Optimizer tool. It basically analyzes your CloudWatch metrics and tells you exactly if you're over-provisioned or under-provisioned. And finally, the hard truth. You have to plan for downtime. For a single instance, stopping it is mandatory. There is literally no zero downtime resize for a single EC2 instance. If you absolutely need zero downtime, you're going to have to use a load balancer and an auto-scaling group, update the launch template, and do a rolling replacement. Now, what's really interesting about this slide is the financial impact of generation upgrades. Beyond just getting better performance, if you're auditing your instances anyway, you really should consider upgrading. Moving from an older generation to a newer one almost always gives you better performance for less money. Just look at the architecture breakdown here. If Intel is your baseline cost, switching to the AMD variants, like an M7A, is typically about 10% cheaper. And if you're willing to update your AMIs to an ARM architecture, switching to Graviton, like the M7G, can literally be around 20% cheaper for the exact same workload size. That is huge. Which leaves us with this final critical thought to ponder today. Take a good hard look at your own AWS environment. Is your current infrastructure perfectly right-sized, or are you just burning money every single month on idle compute? Now that you know the exact steps, and more importantly, that hidden iceberg of gotchas to avoid, you've got the tools to safely adjust and optimize your environment. Thank you so much for joining me for this explainer, and I will definitely catch you on the next one.